Hi everyone, this is Bruno Aziza, and I'm here with Cassie today. This is someone that I've been admiring and following. She demystifies artificial intelligence, analytics, and data for the rest of the world. So I thought I'd pick her brains on a few things today. Cassie, thank you so much for taking the time to talk to us today.
I'm so happy to be here. I think this is going to be a lot of fun.
So there's a lot of confusion around the various domains of data science, machine learning, statistics, analytics. How do I parse through that?
Statistics, machine learning, and analytics, all three together, make data science. So I like to be careful with my language. When I say data scientist, I mean someone who is capable of doing all three and is an expert in all three. So the true data scientist, if you will, according to that definition, is quite rare. Data scientists will use the same tools for the three sub-areas of data science, and they will use the same software. But how they use those tools, what they're trying to do with it, is completely different. Think about it in terms of how many decisions you know you want to make before you begin. So you've got some data. Is it none, a few, or many? And based on that, you're going to approach your process in a completely different way. So if your answer to how many decisions you want to make before you begin is a few big, important, juicy decisions, that is statistics. And the very fact that these are such important decisions, like should I release this medication or not? Should I launch this machine learning system? They're so important that you should take them very, very seriously, go very carefully, and approach them rigorously. And so you need that philosopher, that epistemologist, essentially, that is the trained statistician, who's going to very carefully take you through this very important decision that you have framed carefully, that you're already aware you want to make. If you are automating, if you're making many, many, many repeated decisions, that's machine learning and AI. Totally different approach, oriented on the performance of the automation. But what if you don't know what decisions you want to make at the beginning? You've got some data, what are you going to do with it? In that case, you need analytics. And so analytics is the quest for inspiration. You don't know what you want from data. You don't know what your unknown unknowns are. And how are you going to discover that? How are you going to ask good, important questions about them if you don't even know what there is to ask about? And one of the areas where people miss out a lot is they think that analytics is some kind of mediocre version of the other two. And they entirely end up going down the wrong rabbit holes, solving the wrong problems, because they're not aware of what analytics appreciated as analytics can bring them.
Yeah, so they think about analytics as a poor man's version of data science, and they might staff it poorly then.
A common misconception about analytics is that they are technically weaker in some way than statisticians or machine learning people. The height of excellence in analytics quite often requires higher standards of technical skills than the other two.
And how does data science and analytics fit in decision making?
What I like to tell decision makers about the decision-making process generally is, imagine that you had never had any senses or any context about your world. What decisions would you make and how? Where would anything come from? The reason that you're able to frame decisions in the first place is that you've enjoyed the benefit of human experience. And your senses have taken in information, data from the world, and stored it in your cranial wet stuff. That's still data, and you're still processing it. You've been doing analytics. And what happens when you allow your senses to look around is you begin to see all the different areas that you might be interested in. You begin to get inspired. You begin to get context. You begin to know how to actually ask the right questions. And so you have this broadening of your horizons through analytics. That's what we call it when we do it with electronic data. But I don't actually like to make a huge distinction between what you do naturally with your senses and what you do with the electronic data. Just think of the electronic version, the experts in it, as being much, much faster at looking around than you might be with your natural senses. So you do this broadening. And then, well, you've looked around at all these things. What's actually important? What's worth pursuing? You're overstimulated. Now you need to take something that is the decision maker's skill, that core piece of judgment, and look at all this with your experience, with your business skills, with your good sense and decision-making training, and now you whittle it down to what is a priority, to what is most important. And then you get your most important questions, and these may involve something to do with automation or repeating some decision-making a lot, or they may involve a few very important decisions or a few very important questions. That would be statistics. And so this expanding of your horizons, that's where analytics comes in. And what happens in many companies is you skip analytics because you have this push that you need statistics. And so you end up getting really, really good answers to the wrong questions because you haven't had this process where you've broadened your horizons and gotten the right questions asked. And so if you think about machine learning and statistics as narrow pursuits, very, very narrow and deep pursuits, the shape of a rabbit hole, incidentally, then how do you know what's worth digging? How do you know which rabbit hole is worth going down? You won't if you haven't taken a broad and shallow sweep. And that's what analytics does for you. And analytics is as powerful and difficult and rewarding and challenging as the other two. And I tell people, look at this broad and shallow sweep and turn it sideways. It is as narrow and deep in its own way as the other two. But you have to see it from the perspective of what it is and what it's for, to approach it properly, to manage it properly, and to get the most value out of it.
When you think about the differentiation between the disciplines, you'll always think about, should the teams be separate or should they be on the same team? Because a big part of decision making is it is a team sport. And so how do I bring the folks that are assigned to these three what appear to be distinct disciplines into one? Do you think that having them all on the same team is beneficial, or should they be on separate teams?
I think that the way that you approach building the teams should be based on what you're trying to achieve or the capabilities that you're building. First, you need to diagnose what you want. Are you investing in a better ability to encounter your unknown unknowns, to sense your environment? If that is what you're doing, you can have a team of analysts with decision makers, and you don't need to worry about any of the other kind of professional. Because in fact, the tools are the same among these experts, it's just how they're used that's different. Now, sometimes it might be good to have a statistician or two around in the wings just to kind of put a damper on the exuberance. Something that I like to tell analysts is, there's one golden rule of your profession. Don't make any conclusions beyond your data. So, two ways that you can think about statistics versus analytics. Analytics is where you get your good questions. Statistics is where you get your good answers. So analytics is not where you get the answers. Don't trust the answers if we're dealing with uncertainty. The other way I like to put it is, if you think about what's in your data, your sample, and what's beyond your data, the analyst deals with what's in the data. And the statistician deals with what's not, what's beyond that data set. And so an analyst needs to stick within the boundaries of what their data set tells them. And if there's a temptation to go outside of that, now you need a statistician, which could be the analyst themselves. Sometimes folks wear two different hats, but you should take a statistical approach to leaping outside your data set. So as long as you stick to within the data and only make conclusions about what's there, and then you keep your language careful, you don't say, we conclude, you say, oh, there's something inspiring here. Maybe this would be worth pursuing with a statistician. Then you can do no wrong. You should quickly visualize the data, get as much sense out of it, and say, well, what is in here is this. Does it inspire you, decision maker? Do you want to do something more with that? In that case, go to a different expert. And even in this, there's some implied advice, that perhaps you might want the statistician on a different team entirely. Because there's a little bit of temptation, confirmation bias, which happens within the human, but it can also happen organizationally, where an analyst discovers some beautiful insight, and then they fall in love with that thing. And there's a lot of temptation to go and find and prove that this is not a red herring.
How do you think you would solve that as a CIO? Is it how you staff, how you set the projects, how you fund them? What are some of the tactics that you see people are using to really be successful?
One of the easiest cultural quick fixes for data science excellence that everyone should be making, and I don't know why I still have to, in 2020, talk about this, but there we go. It's a very 20th century problem. In the 20th century, there was not that much data to go around, usually. A tiny little bit of data. And so what every data science professional learns, and hopefully remembers, is that a data point can be used for inspiration or for rigor, but not both. So you can't use the same data point to ask a question and then answer it rigorously. Not when there's uncertainty. Not allowed. So the quick fix, the trick, is if the problem is that you've got one data set and you're being forced to choose between inspiration, good questions with no answers, or rigor, but perhaps a good answer to the wrong question, you're forced to choose between that. The quick fix, if you've got lots of data, is take that data set, split it into 2 data sets, hand one to the analysts, hand the other to the statisticians. So leave the one that is for statistics, leave it hidden in escrow, essentially. No one's allowed to touch it until a decision maker has looked at these potential insights that analysts have brought them and said, these are worth opening our secret stash of data for. Because then you've got a question that fits the patterns in this data set. And if you want to trust that these patterns exist also outside this data set, then you had better come and show that it still holds up outside that data set. We use this principle in machine learning. Same principle in machine learning. Testing is very important. You should never test your machine learning system on the same data that it learned from. You must always give it a fresh data set for testing. And so there's a lot of good sense in putting statisticians somewhere outside of the group that has an incentive to launch a machine learning system. So you've got the statisticians checking that the machine learning system also is worth launching. You've got them checking the analyst insights. You might have decision makers, stakeholders at various levels in the organization delegating decision making, but also having some data stashed and some statistical team where they can check whether or not there's some little bit of wool being pulled over their eyes, because there's some strategic persuasion that happens with data. We understand this, even though we might not love it. Maybe you should actually move it to someone who doesn't have an interest in proving that conclusion holds. Someone who's a little bit more independent.
An outsider. Outsider to your team.
So you can avoid this confirmation bias.
Yeah. Then if we look at machine learning as a process, machine learning folks, this automation with data, they say, well, now we've got all this data, do we even need statistics? Do we even need analytics? And here's what I say to that. If you want your system to work, you need the statistics. So the goal in machine learning is let's automate, let's make it work. If you don't care about whether it does work in the end, then fine, go ahead without statistics. But if you want quality and you want to make sure that you're not putting rubbish out there, you need the statistical review. Now, what about analytics?
Yeah.
Sure, you want it to work, but you don't care how long it will take to develop the project? You are willing to take a century developing it? Sure, go ahead without analytics. Try throwing the kitchen sink at it slowly, one at a time. Or, to speed things up, consider using analysts. The analogy that I give here is, imagine that you need to put ingredients into making an actual food recipe. Machine learning is about creating recipes. We want ingredients to go into recipes, but you don't know what ingredients you need, right? Your ingredients are your various features in your data. So which ingredients should you use? And you've got this massive warehouse, all dark. And where do you begin trying things out for your recipe? You don't even know what's in this warehouse. So would you like to sort of put your arm in and grab an ingredient one at a time and try shoving it through your various appliances? That doesn't sound very efficient. Or you could take the analyst, who is the person on roller skates armed with a flashlight, and allow them to just skate through your warehouse quickly and say, that's a bag of flour, that's promising, that's eggs, that looks kind of good. And then after they have brought some inspiration back about which ingredients you might like to try, then the machine learning comes in. So that's a collaboration there. So I would love to see analytic skills within a machine learning team to accelerate the process, to make sure that it goes faster. So I want to embed them there. I also think that having machine learning engineers helping analysts in the other direction is great, because you can do a lot of beautiful things with machine learning algorithms that are for analytics. unsupervised learning is essentially, let's put like with like. We don't know if that's interesting. We're not trying to automate anything specific. We don't have standards of quality. But let's see if something inspiring comes out of this. So putting folks who've got some additional skills on using these algorithms with an analytics team to accelerate that team's ability to look at data is a very, very powerful thing. So there are ways that you can structure all of this, but you have to start with what are you trying to do with respect to your decision making? And then there are steps in each of these processes. I've blogged about them plenty, the 12 steps of machine learning. You do this, then you do that, then you do that. There's a clear place in these steps for how an analyst would contribute. Clear place how a statistician will come in.
That is excellent guidance, and I hope people follow you on those blogs. And as a follow-up from this video, I've got another question that is related to it, which is, now you've talked about the practitioners and how they can organize themselves. I'm curious about the people that they serve, because sometimes you think about AI automating the decision-making process with auto analytics, auto suggestions. So you basically data preparation, auto data protection. There's a lot of areas in the analytical or the decision-making pipeline that you could just kind of eliminate, so you can use humans for what they do best, which is apply judgment.
Let me start by answering this way. In someone who claims to be at the height of analytics, I want to see very strong, what you might call machine learning skills. They're not using it to automate anything, but they're using it to accelerate themselves, because the analyst's excellence is speed. Anything that makes you faster is better. And a lot of things that you might have done by hand in a very slow and laborious way, you can do very quickly with AI tools that accelerate the analyst then. So, for example, you might have a whole lot of information on, let's say, reviews, user reviews. Did they like something, didn't they? But it's all freeform. An analyst might go and read every freeform response and then tag that themselves as was it good or bad, and then they can visualize what were the characteristics of the vendors or salespeople who led to the bad reviews versus the good reviews. That would be nice standard analytics. But instead of going and reading those 10,000 reviews themselves, they could apply a machine learning sentiment analysis system quickly to it, and they would do it very quickly. They would know that this thing would make a lot of mistakes, and it wouldn't be nicely trained on their data, and it would probably not be the kind of thing that you would want to do if you were going to deploy this. But they can use it quickly to clean up their process, to quickly categorize, here are the ones that are obviously good, here are the ones that are obviously bad, and then they can fine-tune by hand themselves in the middle, meaning that they personally then only need to read a few and not all of them together. So because analytics is all about speed, when you take this attitude of how fast can you bring inspiration, and you evaluate everything from that perspective, you also begin to see what the process needs to look like, what the tools need to look like, what the collaboration needs to look like, and what the staffing needs to look like. And there is so much that you can do to make yourself faster and better at absorbing information.
I want to stay on that theme of speed and automation, because I think one of the big struggles CIOs are faced with today is, what are some of the tasks that I can automate effectively, and what are some tasks that I can never automate? Do you have a mental framework to help them think about that? I mean, there's the obvious, okay, if it's highly repetitive and doesn't require a lot of IQ, or you can just rinse and repeat, but how do people think about that?
Yeah, so that's a beautiful question. And one way to think about it is, how do you know that the answer is the right answer? Is this a task where success is easy to measure? Are the metrics clear? If it is very easy to say whether a task was done correctly, and there's relatively little ambiguity from human raters on this task, then that one is a good target for automation. So let's say the classic cat not cat task. It's very difficult for us to say, what is catness? How do I describe what makes a photograph catty? That's difficult to do. But it's easy for us to look at it and say, that's a cat versus that's not. Now, there are places where humans will make mistakes or disagree with one another. Oh, that's not really a cat, that's a cartoon of a cat, and someone else will call it a cat. I have an example that I love to put up in front of decision makers where I say, okay, answer cat, not cat on a bunch of photographs. And it's very easy until we get to the photograph of a tiger. And then half the room says cat, and the other half says not cat. And I say, come on, you only had 2 allowable answers here, cat or not cat, so which one is it? And the answer to that is it depends on what you were trying to do, on how your project was framed. What would the right answer be in this case? And the more ambiguous that is, the harder that task will be to automate.
Okay, this is a great way to think about it. So instead of the way the decision is made, is the way the output of that decision is being interpreted and worked with is the guiding light for automation or not. Wow, that's
Right.
really good guidance. I did not think of that. Well, Casey, thank you so much for your time today. I feel like I could talk to you for hours. Thank you so much for doing this. I want to encourage people to engage with you on LinkedIn, on Twitter. I know you're very active. And you also have a newsletter on decision.substack.com. So I want everyone to go out and subscribe to that so they can stay in touch with you. Thank you so much again. And for everybody else, we'll talk to you soon.
This was
Bye-bye.
really fun. I really enjoyed it. Take care.
Me too. Thank you. Bye-bye.
Bye.